Good afternoon, everybody. Welcome, and thank you for joining us today. Our webinar today is hosted by Worldwide Supply and Network Distributors. Just do a quick screen share here so everybody can see our presentation. Our goal today is to help our service provider customers better understand the dynamic market of high performance application optics and open optical transport. We should have about 40 to 45 minutes of content to discuss, followed by plenty of time for Q&A at the end of the hour. Should you have any questions, please submit them using the chat. We will be recording today's session, and we'll send the email out to everyone with a link to access the webinar at your convenience as well. Today's agenda: we will be discussing high performance application optics, some of the strategies that are being employed by the leading providers today, of course, some emerging trends and technologies, and we're going to highlight some products for you as well. We'll get into a little bit of XGS-PON and some of the applications that might suit your business and how to implement those strategies within your network configurations. And then, of course, open optical transport as well. I want to highlight for you in that category some of the drivers that we all are somewhat familiar with that are driving us towards that open approach. And then Ralph's going to highlight for us some of the methodologies used that are most effective for our customers today. Before we begin, just want to introduce ourselves. Your hosts today are Worldwide Supply and Network Distributors. Most of you got here today by way of an invitation from someone at Worldwide, so it might be safe to assume that many of you are familiar with Worldwide and what we do. For the handful of people who may not already know us, for the past 20 years, Worldwide Supply has been a provider of new and pre-owned networking hardware and related support services. Founded in 1999, Network Distributors is the industry's premier provider of compatible optical transceivers, optical transport solutions, and open network switches. Worldwide Supply is an authorized reseller partner of Network Distributors. My name is Brian Dugan. I'll be your moderator today. I am the Vice President of Sales at Worldwide Supply. Our presenter, I like to call him the Professor, is my friend Ralph Marone, who is Vice President of Sales and Product with Network Distributors. So as we all know, and the reason we're all here today is to discuss this exact topic, but let's lay a little foundation first. Service providers are running optical fiber much deeper into the access network in order to deliver higher bandwidth, making it possible to offer a customer experience that is better for voice, video, and data services. So this is the perfect place for us to start today's conversation. Ralph, can you provide a little backdrop for us on the total broadband market here in the US and what the industry experts are projecting for the near future?
Yes, thank you, Brian. The marketplace for broadband expansion is close to $150 billion worth. Whether it's RDOF, whether it's state and local funding, private investment, everybody has the need for it and investing in it. So if you look at the chart, it says by 2026, it's going to be about $400 billion worth of broadband services. Of that, about $30 billion is going to be the FTTX marketplace, because there's several different ways that you can deliver services. FTTX is only one of them, but that's the one we're going to focus on today. With these markets growing at about a 13% rate, there's various ways that you can put an all-fiber network in. We're going to focus on XGS-PON. But just some little fun facts for you. I the other day told Brian I could get 10 gig at my home. Well, I called up Verizon and said, that's in Boston, by the way, and they said, we really don't have that offer and we can only give you 1 gig to the home. Xfinity says we can give you 6 gig to the home now. And they called them up and they said, we can really give you 1.2 gig. Talked to a number of suppliers that are actually going to offer 1 gig service at $19.95 per month rates coming at the end of 2023-24. So the point being is the rates are going up, the cost is going down per bit. So
always Sorry, Ralph, after you.
Go ahead.
It just occurs to me that, like, I think of when I started in this business 15 years ago, and the numbers you're talking about now weren't even a pipe dream back then. And it's just staggering that it's like, it's common course. So as we look to get more speed, more distance, and all of us as consumers want to spend less, how are the providers going to deliver that, right? Like, what are the nuts and bolts of that delivery method? And so, as you mentioned, we're going to focus first on something like a 10 gig fiber to the X PON network with 100 gig access. So what can you highlight for us here, Rob?
Of the several hundred companies that we track that are putting FTTX networks in, a majority of them are using XGS-PON. Some are using straight GPON, or some of them are just using straight gray optics or CWDM, DWDM to give you the capacity. But in this case, this is a diagram that shows from the core on the left-hand side all the way to delivery on the home and business on the right. What's the key point? The key point is the speeds that are in the access ring are moving close and close to the home. I talked to a supplier the other day, and he said, yeah, a lot of our customers are already telling us that they're bringing 100 gig within miles of the home. They're expecting to have that kind of capacity to be able to offer 10 gig service. So point number one is access on this in the ring portion is what we're going to talk about, especially from an XGS-PON perspective, and especially from the OLT perspective. The other points on this is there's a lot of different places where you can use optics. Core all the way through to the home, we offer everything from 400 gig optics into the core, 400 gig coherent into the core, and then 100 N XGS-PON optics we're going to talk about later.
So taking it one step at a time, let's break it down into its different elements, right? When you talk about delivering 100 gig closer to the edge, there are 5 technologies that are most commonly used. Today, we're going to focus on 4 of them. Gray optics, and as a reminder, that is defined as either single wavelength or fixed multiple wavelengths. We'll talk about BiDies available at 100 gig, QSFP 28X, and optical transport with coherent optics. So let's go one by one, right, Ralph? Let's start with the grays, but before I go too far, can we just take off the table? We said there are 5 most common, but we only want to talk about 4. We're leaving out PAM4. Do you want to give everybody an idea of why we set that one aside?
Because of the clientele that are typically our customers and the people that are on this teleconference, PAM4 technology is typically those who need a lot of channels of capacity. That means the cost for PAM4 goes down when you deploy a lot of channels. In our case, if you're looking at only 400 or 800 gig worth of capacity, then it doesn't have a cost-effective trade-off. Additionally, the engineering cost and the support for PAM4 is a requirement for those who have strong engineering teams backing them up. We're not saying our customers don't have it now, just that it is going to take it, which means smaller companies will have to rely on their internal engineering team for putting PAM4 in place.
Yeah, so just to sum up, right, the unique applications, the complexity, and the price make it just a less common fit for most of our customers. I mean, that makes perfect sense. So let's set that aside and let's move into the subjects we really want to focus on today. And let's start with the grays.
Sure. Can you go back to the previous slide there? So
yes,
talk
sir.
a little bit more about it?
Yep.
Okay. This slide shows the distances that you can achieve versus the capacity or the speeds on the left-hand side. If we're starting from the bottom, we're going to talk grays, we're going to go into BiDies, we'll go into QSFP 28X, and then we'll go into DWDM coherent for a transponder perspective. A lot of our customers right now are using gray optics. An LR4 is our standard optic, which is a height runner that everyone is using. 10 kilometers at a click. It might be something along the lines of a gray application for gaming company. We've heard people have built their whole entire network for low latency and be able to have low overhead using 10-kilometer hops between it. So standard gray optics is where we see most people right now investing in, besides the coherent optics for longer distance transport. So next slide, Brian.
Yes, sir.
Okay, so this is kind of a a chart that's got decipher here. Everything in blue circles are those that are 4x25 gig rates. So that means 4 lanes of traffic, 400 gig. It means though that still that they are all gray optics. Anything that is in black, which is on the bottom left-hand side, the DR through the ER1s, they are all single lambda. And that is a 1 times 100 gig. They are up and coming and starting to have more and more market share, especially with the hyperscalers and the data centers. What do we see though? We see everybody using the LR4 technology. Primarily, LR4 is number 1, ER4Ls, and ZR4s. Here's a ratio. For every 10 LR4s that we sell 2 ER4Ls and 1 ZR4, kind of 10 to 2 to 1. And now we're starting to see about 25% of our products, especially in the LR4 and ER4L and ZR4, are becoming industrial. And that's because people are deploying these, especially in hot climates, we start to see that most being used. So we have up on here, those that are green are established products. Those that are red are what we consider new products. So in ER4L industrial and ZR4 IND, last December, there was really no one actually deploying ZR4 INDs from our perspective because we didn't have the products. When they became available, now a lot of people are asking for them. What's also new is the EZR4. That's extended ZR4. That's a 100-kilometer part. We recently have gotten multiple suppliers of them. We've qualified those in our lab into various brands, and we can do 100 kilometers worth of fiber as well as a 5 dB attenuator in it, which means it's in excess of 100 kilometers, we're able to establish link. So we've proven whether it's an ER4L, a ZR4, or EZR, we test them in our lab with fiber case links, and we put them under bit error rate tester for long time periods to ensure that we can achieve the distances that we state they can. So the bottom line is a lot of different ways to be able to get there. DR and FR and LR, they're single lambda. When would you use a single lambda? Well, a single lambda would be used if you're using 4x100 for a 400 gig breakout. So you need single lanes to be able to get them to go into a 1 lane of 400 gig. You can't use LR4s times 4, which would be 16 lanes. Technology doesn't work that way. So we're seeing more and more people start to ask about the single lambda. They're 20% less cost, they are less parts count, but the problem is they don't talk to an LR4. So it's an LR1 talk to each other. FR does. So they're not interchangeable. But you're going to see more and more people start to transition to it when the OEMs support them and when the price of the optics themselves is greater than 20% less than a standard LR4.
Yeah, Ralph, from our side, the increase in options across the board here, which have been many in the last handful of years, for our customers at that 100 gig level in grays has been a total game changer. What comes up a lot in conversation too, and we want to talk about next, is what about our friends out there who have fiber constraint, right? What are the options for them for BiDis at the 100 gig level?
Yeah, the first thing to say about BiDis at 100 gig is that technologically for 100 gig wasn't there until recently. It really is only started coming strong in 2022 timeframe. So BiDi is pretty basic, 2 different wavelengths, both wavelengths can operate on a single fiber. So the advantage is that it's great when you have fiber constrained environments, just as you said, Brian. So what's available for 100 gig optics right now, and why would you use it? Well, here's an example. As a utilities company that I visited a while back, they are all expansion is state regulated. So they only have a certain number of fiber lines that they have, but they want to go to higher speeds. So they said, we're going to take out a 10 gig gray and we're going to put a BiDi, we'll give 1 fiber in there to get us 100 gig capability with it. So you can see where you have only 8, 10, 12 fibers running on the ground or in the air. It's a problem, especially if you're trying to connect 100 gig longer distances. So the 2 common use cases, rip and replace 10 gig BiDis with 100 gig, or doubling the capacity in a fiber pair where you can use the second half for another application.
let's look at a couple of the specific products and the descriptions of them so you can help everybody understand what is out there today and what's coming.
Okay. So the current technology available are 10 kilometer, 20 kilometer, 30 kilometers, and stopping at 40 kilometers are just becoming available. The challenge in 40 kilometers is the chromatic dispersion and the limitations that you have to get you that kind of distance. Anything in black on this chart we have available now. Anything in red is on our roadmap. Our 40 km single lambda BiDi, that means it's going to be a 100 gig lane. To be able to get you a BiDi part will be available in, let's say, July of this year. We should be seeing DBT reports and environmental testing early June. It'll be in GA by the end of Q4. Same thing with the 80 km. That's a 4 by 25 gig. The reason I had to do that is because when you go in the extra long distances, the lower data rates don't have the impact of chromatic dispersion also. Samples will be available in Q4 of 2023 with those. So right now, 10 to 30 is available, 40s and 80 coming.
Yeah, I know you and I have been a part of a few conversations of customers who are waiting in that line, right, to see when those come out before the end of the year. As we shift over a little bit, let's add to the equation QSFP 28X and what those access rings look like when you implement this strategy.
So QSFP 28X is trademark our name for a technology which is an NWDM technology. What NWDM is a standards that was published in 2021. A lot of the NEMs and the manufacturers of the optics got together and they have created this standard. It allows you to be able to put an amplifier and chromatic dispersion compensation within the optic, which means it's a direct plug and play into your switch or router. So the only thing you need to do is to add a passive mux or demux. So what's shown up there is 8 wavelengths that we have that are operating at O band that you plug in, and if you want to get 400 gig, you plug in 4 channels through a 4-channel mux, and that allows you to be able to go a distance up to 40 kilometers plus. This is distance limited. You can only get to 40 kilometers with about 400 gig. We put this in play in a state here, local here, where we had a police department connected together with 2 public utilities, and they wanted to run a 200 gig backup as to their normal routes, just so they have a redundancy. So we put in basically a 42 kilometer link, 2 channels of it, and a 2-way mux in it. Great performance, easy to do. All they have to do, plug and play, low cost solution. So it's got the ability to be able to give you a negligible footprint, very low cost in terms of the hardware itself, and it's easy to implement.
That's fantastic. As we talk about the evolution of PON, right, and we move into what is becoming more and more prevalent in networks today in XGS PON. I'll show an illustration for everybody here. Just a couple of years ago, XGS PON only accounted for about 15% of the overall PON market. And you're going to see a flip to the majority within a couple of years. It looks like, according to some industry experts, that it might be as high as 55% of the PON market, Ralph. Why exactly is that?
Yeah, well, there's a lot of competing technologies, but it seems like XGS PON is first easiest to implement. It's a 10 up, 10 down symmetrical, or 10 down, 10, 2.5 up. That's what's called dual rates. We'll get into those later. And it's one of those where everybody has chosen XGS PON because it is cost of implementation, cost of the hardware, and ease of the technology. There's 100 different ways that you can put a PON network in play. So GPON has been around for 30 plus years or so. And a lot of people are running out of steam with a 2.5 gig down rate that they have and a 1.25 up rate. So there's a lot of people with brownfield deployments that actually have PON already placed, GPON, and want to add XGS PON. And we'll be talking on the next slide about the combo parts. But the bottom line is most of the new people that are investing in FTTX, if they're going with a PON technology, are going with XGS-PON. There are others that are doing NG-PON2 and other types of PON, and they'll go to rates that are 25, 50, 100 gig in the next 2 to 3 years. But most we see in our market, tier 2 and tier 3, the smaller service providers are going XGS-PON.
Let's, you mentioned it already though, let's jump there. Let's highlight some of those products and how the form factors and classes differ.
Sure. So we focus on 4 main brands: Calix, Adtran, Nokia, and DZS. Of those brands, we see them deployed everywhere in the United States and in the world. We also do some still Huawei and ZTE, but with the, let's say, political issues with Huawei and such, we see that's much less, but they're still in places like South America where it's being deployed. What do you see on this chart? Anything in green is XGS-PON related. So there's 2 things that are important here. One is that there's form factors that are SFP plus and SFP DD. And it depends on the manufacturer what they're going to be using. So when I say a single rate part or dual rate part, that means it can only do XGS-PON. When I say combo, that means it can do XGS-PON and GPON both. So Nokia and Calix combo parts are or will be SFP DD, double density. I say will be because Calix doesn't have them out available. We understand from what our customers tell us that they'll be available by the end of this year into 2024. Nokia already has out the SFP DD cards to be able to support it. They're FANT H cards. Adtran and DZS combo parts are SFP plus. So you got to match up the product types with the OEM. We've qualified Nokia Adtran, both single and combos. We've qualified Calix single rate parts, that's the XG801 card. We have DZS in qualification, expecting it to be complete by Q3. Any Calix combo parts will need to be sampled and tested in customer requirements, customer equipment. So the final point on this is there's a lot of different classes. So if you look at N1, N2 for XGS-PON, there's also some higher power classes that are available. The ones that traditionally are asked for would be N1, N2, but there's also +2 and +4 dB additional power, as well as additional receiver sensitivity. There's also obviously C-temp and I-temp. Pretty much anything you're going to be seeing for a Nokia part is going to be an I-temp. Pretty much we see a lot of I-temp for Calix also. Others may be offering C-temp parts.
Sure.
Point is, portfolio is all there for XGS-PON.
Yeah, that's great. Now let's take just one step back, or I guess one step up maybe, right? And let's just focus for a minute. We talked about the XGS-PON network. Let's take one step up and talk about the optical transport market itself. Don't really want to go out of order here and go up and down and up and down, but when I think about the market, right, it's important that people understand who are the primaries that have driven this market historically, and then how does that lead us into how things are changing and how the market for open optical transport is changing and how people can approach this for their networks.
Sure. So optical transport, well, it's the term that I basically think of whenever they're connecting a core data center to an access distribution. It is the backhaul and the large capacity requirements for getting back into data centers. A lot of people define it different ways, but that's how we look at it. So the North America optical transport market really surged in 2022. COVID driven, broadband video driven, newer applications like medical, remote monitoring, artificial intelligence, all those things are driving the demand for it.
Federal grant money, right?
Pardon?
Federal money going that way.
Absolutely, yeah. So people want to be able to put a lot of enterprise business for applications where it might be enterprise to enterprise needing broadband with and video conferencing or even connecting equipment together. So who's there? Ciena, Fujitsu, Infinera, Cisco. They've traditionally controlled this marketplace. They have 80% of the North American marketplace. So when you buy a system from them, and typically you use a muxponder, transponder, or a ROADM-based system, they are going to be from a traditional monolithic system. They're high cost in capital equipment. They're expensive to support and complex software to do. They're locked and basically lock out by a license.
Yeah,
But the
let's
growth
look
in
at
the
how
market
that
is still,
compares. Yeah, I'm sorry,
yeah,
Ralph.
how's it compare?
Step on your
Okay,
toes.
is look at the open networking, multi-vendor, open source, no licensing required, simpler software, lower cost, easy to deploy. Basically, you set a box up, you program it, you put it in place, and you can forget it except for your monitoring of it. So if you're going to tie into your NMS and you want a traditional type of system fully integrated from your NMS all the way through, that's not our products. But if you want a low cost way to be able to put transport in place and be able to get a couple 100 gig, 400 gig, 800 gig, 1.6 terabit of data, and you want it for low cost, that's where our specialty is.
Yeah, I mean, a lot of what we do, and one of the things that you specialize in really for our customers is all about options, right? Giving them options, giving them choices that they otherwise wouldn't have. And certainly this is powerful. And the more over the years you and I have worked together on these kind of solutions, the more our customers here at Worldwide have just absolutely opened up to the possibilities that they didn't even know existed before. And if they knew they existed, they weren't really comfortable with them. And this explanation you just laid out here is real straightforward and easy to understand, even for somebody like me. So that's fantastic, Ralph. When we get one level down to the products, can you break down for us, like, what are the connectivity and the products that and how they relate to each other in that setup?
Don't want to make this a product presentation at all, but you got 4 components. Obviously, you got the transceivers, and that's everything from a long distance gray optic all the way to a coherent. You have transponders and muxponders, which allows you to be able to go from one line rate to a client rate. Example is someone who already has 10 gig in place and wants to go 10 by 10 to a 100 gig coherent to be able to put it on one fiber pair, can muxpond those all together. You also have what's called line systems. That is amplifiers, monitoring, OTDRs, dispersion compensation, all the things necessary for longer distance applications and PAM4. And finally, you need the passive products and the components, which are your muxes, demuxes, splitters, couplers, things like that to tie it all together. Those are the 4 things that make up WDM. We're going to give a couple examples, like in the next slide, about how they're used.
Let's do that.
So this is an example where we connected 3 cities together up above the Great Lakes. And it had where they wanted to go from one city to another, about 90 kilometers. I changed some of the numbers to make it so it's less particular to their application. They needed to get 100 gig QSFP28 ports on the client side, and we used the CFP2 DCO on the line side. Why? Because it's plug and play directly into the muxponder, no amplifiers required. This 2U chassis combination allows you to go 3.2 terabits worth of capacity, which is 400 gig times 8 cards at 3.2. So a 400 gig muxponder coherent will connect unamplified, in this case, to a link greater than 80 kilometers. What we do have, though, is a lot of different form factors. We have 100 gig, 200 gig, 400 gig muxponders. I'm sure we'll be offering 800 gig and above when we see the demand for them. So next example, next slide, is this happens to be one of our 200 gig muxponders. Well, it's only a 1 RU. And if you look at it, it has 4 slots in the 1 RU. They also have a 2 RU and a 5 RU version. But look at all the cards that you can put into it. Transponder cards, amplifier cards, OTDR cards, wavelength selective switch cards, video controller cards for more of the video world, all kinds of specialty cards they have. The point is that we have about 5 or 6 different platforms that will match up your needs with what the hardware offerings that we have.
Now, Ralph, let's step it up a notch to the 400 gig products, right? 400 gig's been around for a couple of years. hasn't quite reached the mainstream of our customer base yet, but definitely end of 22, we saw a huge uptick in demand for requests of people looking for pricing and availability on these products. So the costs of those 400 gig optics have certainly come down considerably. The OEMs are delivering on the 400 gig switching platforms, catching up from some of the COVID challenges and the lead time constraints. And so as they catch up, the customers are able to start implementing some of these solutions. What can you highlight for us here on what's available today and what's coming on the 400 gig products?
Well, basically, you either have optics, AOC DAC cables, and MUX ponders. We're going to focus just on the 400 gig optics right now. What's in green are those that we commonly see for the tier 2, tier 3 telco customer, predominantly FR4 and LR4, 2 kilometer and 10 kilometer optics. What's in gold is the QSFP-DD 400 gig ZR and ZR pluses, which we have some slides coming down after this to talk about performance of it. It also includes the future ZR Plus Bright, which will be a 0 dBm or perhaps even higher, maybe +3, option to be able to give you longer distances unamplified or for use with ROADMs. So what do we see? Well, first thing is on the gray world, if you see an FR4 and LR4, well, those are people that are already have sampled those in 2022 and started to get into low rate production or volume production, where they need to start either connecting data center, or they're going from site to site at 400 gig. The coherent, and this is where I get asked by everybody, how far can you go with the ZR Plus? What's an unamplified distance that I can go? When will a ZR Bright be here? How difficult is it to deploy a ZR Plus? What do the OEMs support now? What do all the brands say? When are we going to be able to just drop them in place and be able to have them all qualified? Those are the questions we're constantly getting. So what I'm saying now is a lot of people are in the wait and see mode of the 400 gig ZR Plus, and those are saying we'll need it in 2024, 2025, but we want to start sampling this year. So what have we done?
You want to jump to those specs and test results and come.
No, let's talk the IP over DWDM.
Okay, that's cool. Yeah, we can do that. I mean, what is all the buzz about when it comes to IP over DWDM, Ralph?
Okay. So it's the term that everyone says. Cisco has a whole plethora of information on it. Everybody talks about it. This was taken from Windstream Art Nichols' presentation with Signet AI beyond 400 gig. It was a great slide, so I thought I would reuse it. It's basically saying, how do you evolve from what's currently deployed now to pure IP over DWDM? So up on the left-hand side, it shows 100 gig clients that are actually connected together to a 400 gig coherent transponder. On the right side is 400 gig optics connected together with a 400 gig transponder. Those eventually will be compressed down to 400 gig plug directly into an L3 or L2 router switch, and you will give up on rack space, power consumption, complication of system, all those things you'll get with an IP over DWDM. Direct router to photonic layer connections. That's what IP over DWDM is all about.
Straight shot. So
Yep.
let's circle back now to what you had referenced earlier, and just for people who are obviously, when you start talking about the 400 gig ZRs and ZR pluses, the things that all our customers are going to want to know, right, is the validation side, the testing side, the engineering capabilities where you can produce test results and examples of what the performance verification really is on these products. And so I'll give you a minute here to kind of walk everybody through what you've been able to do there.
Yeah. And why is this done? Done for a couple of reasons. One is because from a marketing perspective, I can only tell you how many times that a customer has said to me, well, the OEM data sheet says I can go 120 kilometers with the ZR Plus. What can yours do? So you have to qualify that because that 120 kilometers with the ZR Plus is amplified. So what we did is we put together a test bed so we could verify various lengths. We verified those lengths using OTDR so we know exactly what they are. We have both pluggable QSFP 28 amps and 1RU EDFA booster and preamps line racks. We also had 8-channel, 16-channel muxes, demux is in the lab. Top it all off, we have an expensive Viavi 400 gig dual port BER tester that's used to generate the traffic and do the BER measurements. That's our test setup.
We want to show a little bit about what the receiver sensitivity shows.
Yeah. Why did I choose this? I chose this for a reason, because one of the reasons that you question distances is what kind of output power can you get, or what kind of receiver sensitivity do you have? According to the standards, so if it is OIF for ZR or Open ZR Plus for ZR Plus products, two different standards that drive them both, they have minimal acceptable performance out of the receiver and transmitter. Well, in this case, a ZR typically is spec'd at -20. So one of our suppliers did for us, they analyzed 22 pieces of ZR. They said on average, it's better, as you can see from there, it's about 24, neg 24, which is 4 dB better than the spec. They said, we're gonna be conservative and we're gonna spec it at neg 21. So the point being is, if you can get a hotter juice on the output, or you can get a better receiver sensitivity, you're gonna be able to get longer distances unamplified, or especially on the receive side for better OSNR and distances when you're in amplified environments.
Let's jump to that. Let's show some of the numbers when you compare the unamplified and the amplified testing that was done, Ralph.
So let's first say is that our lab fibers are really good lab fibers. They're 0.22 dB per kilometer. Typically in the field, when I look at OTDR plots, they're more like 0.25 or a little higher dB per kilometer. So the number you want to really look at is not the distance, but look at the unamplified total loss, or the amplified loss. So if you look down at test number 1.1.1, no amplifiers, we put 40 kilometers of fiber in, 2 dB attenuator, and we had 10.1 dB of loss. It was using CFEC. This is the first versions we did at 400 gig. So what you do is you look at that 10 dB of link budget, and you say, if my actual loss is 0.25 dB per, then it's about 40.4 kilometers distance mathematically works out to be. We obviously have to confirm this in the field, but it's saying you can get 40. And that's what the brand names are saying, they can do unamplified at 40 kilometers, and we proved it out easily there. Then we also went to 800 gig, where we did 2 ZR pluses with an 8-channel mux. So you see 140 at the bottom at 2 amplifiers, 17 dB and 9 dB fixed pre and post. 41 dB of link budget. That corresponds to 140 kilometers of fiber, plus the losses of all the fiber patches and the loss of the mux demux. That gives us 41 dB. That clearly calculates out to much greater than 140 kilometers. But the point being is, you can, with 2 amplifiers here, get to 140, 150 kilometers. And with the single amplifier, 17 dB fixed, 15, 17, you can get 80 kilometers of our fiber. But again, do the math on the 24.5, multiply it times 4, you get mid-90s for it. If that's a real life kind of estimate, so you're in the 90s for what you might be able to achieve with one single amplifier. Keep in mind, we did these with both pluggable as well as fixed amplifiers. We're going to be doing different speeds, different modulations, different effects, and we flesh out the entire portfolio. This is our baseline to be able to show customers this is what you can achieve with a single amp or a dual amp.
That's fantastic. I had left a little time at the end of our discussion for us to just spend a little time wondering to ourselves, right? Like, how much more can we grow with this? But that's really just kind of postulating on what may or may not happen in the future. Instead of spending too much time on that, I thought we'd address a couple of questions that came up. We've still got another, 16, 17 minutes, but we did have a couple of questions come in actually just before we started the session. We got a couple of email questions come in, Ralph. So can I fire off a couple of those at you and see what you have to say there?
Sure.
Okay, the first one here is we have a GPON deployed. We have GPON deployed and want to build out XGS-PON. How do I choose the right GPON parts? I'm just reading that word for word, so I'm not sure if you're tracking with that 100%.
Yeah, no, I hear you. Yeah.
Okay.
So the question is, if it's a brownfield deployment, you already have GPON in place, and you want to go with combo to be able to support both protocols, or are you going to be expanding with a single protocol? I'm assuming it's a combo application where you're going to support GPON and XGS-PON. So the first thing you ask yourself is, well, what brand are you using? Well, if it's Adtran, we know, or DZS, we know that they're using SFP pluses. If it's a Nokia and soon to be Calix, it's going to be a DD. So the first thing is brand and what client cards they have and what the platforms are. We offer both the SFP plus and SFP DD optics. We get them from several of the large suppliers that actually service many of the OEMs already. So we know that we have the hardware available. What's key is getting them qualified within the latest versions of the line card and the system with the OEMs. We know though, Adtran combo parts, we've been able to get the TA5000 and SDX 6000 up and running very easy. So we've had good success with that. We've just worked with the customer to get the Calix single rate parts done in their lab. We've worked with Nokia over the last year with a client who has Nokia, I should say, and we've gotten their single rate and their or dual rate, as they call them, as well as their combo rate parts up and running.
Okay, great. Thank you. I got one more, and I know you'll know this one too, right? And it's just very simple. When will single lambda parts be here?
Oh, well, okay, so we had a gentleman and us debate this. They said it was going to be here in 2022 timeframe. Well, that kind of came and went with it. That's because he was thinking with the hyperscalers, and he's right. They really have taken and used single lambda parts. We just got a request the other day for single lambda LRs, and we're starting to see more and more of them. I would say that it depends on the equipment manufacturer support. It depends on what the OEMs bring out in terms of the hardware supporting them. But more so is, do our customers want to have a single lambda solution? Why wouldn't they just use LR4s? Why would they go to an LR1? Well, LR4s are pretty much reached the bottom of the price curve. They've come down, and by the way, a number for you is, the number for an LR4 has come down about 27% in the last 18 months. So wow, keep that in mind. Why the decrease? They've flattened out though, because the hyperscalers drove that. But they were buying them at 10,000 or whack. So we take and get the advantage of that. So single lambda is 100 gig to 100 gig. That's when people will want to use those. And it may be now in the future. I think it's going to be 2024. We'll start to see more of the ramp of LR and LR1 products. And LR4s will continue being strong with many of our telcos, because that's what they've proven to have: hermetically sealed box products, proven in the field that work and don't come back.
Roger that. Okay, cool. All right, let me take a pause here and see if we have questions coming in from the chat. And our friend Mark is with us here. Mark, did you see anything come in from the chat while we were chatting? I'm not seeing any new ones coming in.
I did see one new one that came in here, Brian, and this is a wavelength question for you there, Ralph. It says, what wavelengths are used for XGS-PON and GPON?
Okay, so I have a chart. I don't know it off the top of my head, but I can give you the chart that does have GPON versus XGS-PON. They're roughly in the 1500 nanometer range. They're offset each other, and since I just don't know them off the top of my head exactly what they are, I can certainly provide that.
All right, thanks.
Other questions come in, Mark? Or we can take a minute here to see if anyone has questions. They can submit through the chat before we wrap the session. Ralph, this is fantastic stuff, man. I really appreciate it. Every time we get together, it's an education, and today's no exception. So thank you for all of this.
Well, it's my enjoyment of doing this for technologists. I can say is when I had a GPON system installed in my house, and I had upgraded a couple of years ago, I asked the guy, could I go back and see your system in the main street? And the guy looked at me like, what, are you crazy? I said, no, I'm interested in seeing the splitters and the OLTs and everything else what you have up there. So he allowed me to go back. This is Verizon. It's a brick building in the center of West Newbury, Mass. So yeah, we love the technology. It's enjoyable stuff.
Okay, we'll give it another minute here. I didn't see any new ones come in. Mark, did you?
No, sir, that was it.
Okay. All right. Well, with time to spare, we made it in under the wire. Ralph, thank you so much, sir. I certainly appreciate it. And to everyone who attended today, thank you for your time and consideration. We appreciate you being here. And this is just the first in a series of these webinars we're going to be hosting. And feel free to submit to us specific subjects that you'd like us to address on the next session. And we'll get to work on it right away. There's nothing we enjoy more than helping our customers solve these problems. And really appreciate everyone's time today. And thank you very much. Everyone have a good one.
Okay.